Hi, this is Ms. Patterson. Today we're going to go over pH. This is part of AP Bios Unit 2. When we talk about water, things like that, we talk about pH. So pH stands for perhydrogens. This is going to be the concentration of hydrogen ions in a solution. So we're looking at H pluses. These are just the hydrogen protons that are floating in a solution. Here I have a hydrogen. I have one proton, one electron. That's what makes hydrogen, hydrogen. And I can show it like this. I just have the letter, and I have the minus of the hydrogen's electrons on the outside. pH is talking about how many hydrogen protons, how many hydrogen ions do I have in there. Because remember, an ion is when electrons are different than the normal status quo of what's on the periodic table. So hydrogen has one proton, one electron. So when I lose that electron, I become an ion. And so we're talking about hydrogen ions in a solution. So acids are going to increase when I have an increase of hydrogen protons, my hydrogen ions that are floating around in the solution. So again, here I have my hydrogen, and I'm going to have an electronegative molecule or some type of atom. So here I have oxygen. Very electronegative, very greedy for electrons. It wants all the electrons and it doesn't really want to share. So oxygen has 6 valence electrons, 1, 2, 3, 4, 5, 6. It wants 8. Remember, they want to fill that octet rule. So oxygen's going to pull in this electron and it's going to pull in that electron. So it pulls in those electrons. What hydrogen's going to do is it's going to pop off. They're going to pop away. But oxygen's going to keep these electrons because remember, super greedy, doesn't want to get rid of them. So now oxygen's going to be very electronegative. It's going to have an electrical negative charge. Hydrogens are now just protons. I don't have the electrons anymore. Protons are now attached to oxygen. So hydrogen is just a proton, which is a positive charge. So these hydrogen protons are floating around in the solution. I have this functional group. Okay, I have a carboxyl group here. I have a carbonyl with the hydroxyl group. This is going to be non-ionized. And so now the question is, well, why? See here, I have this electronegative oxygen and this hydrogen. So what's going to happen is I'm going to have this electron is going to come over to this oxygen. Oxygen's going to take it. And then when it does, this hydrogen's going to pop off. And now when it pops off, I'm no longer non-ionized, I am ionized. I have a different number of electrons now. So now this oxygen's become an ion. I have more electrons than normal. Hydrogens are now floating around, protons are floating around in my solution, increasing my acidity. So now this is going to be considered ionized. And now I have a hydrogen proton floating around in my solution. So this is one reason why some functional groups are considered acidic, is because I can make acids with those functional groups. So here I have pH of water. If I have a liter of water, it's going to be around close to 56 moles of water. So that means I have 56 moles of water molecules in a solution. And this is going to have a pH of 7. What happens in this liter of water? I'm going to have a very small amount that are going to ionize or fall apart, which means I'm going to have protons being popped off. Now, it's not a lot. It's just a very, very small amount. But I'm going to naturally have this happen in my bottle of pure water. So what goes on is most of my water is going to look like this. I'm going to have hydrogen is going to be bonded to oxygen. It's all going to stay. But then every once in a while, I'm going to have some that are going to pop off. And when they pop off, now I have ionized water. I have water that's going to have ionized pieces of oxygen molecules inside my water. So hydrogen protons are going to float out, okay? And now I have an OH, I have a hydroxide, I have an OH molecule here, which is OH negative, and I've got one negative molecule here, so now I have hydroxide, and I have my hydrogen protons. So now I'm going to have hydroxides, and I'm going to have hydrogen protons floating in my solution. So this is what we call ionized water. And a proton has popped off, and now I have hydroxides floating around in my water. So out of the 56 moles of water, how many hydrogen protons have popped off? A very, very small amount. In this liter of water that I have a pH of 7. All I have are water molecules, but remember, some have ionized. I've had hydrogen protons pop off. So I've only had 0.0000001 moles of hydrogen protons have popped off. It's a very, very small amount. But that's also saying I'm also going to have, on a pH of 7, I'm going to have the same number of hydroxides, OHs, in my water. These hydrogen ions are also going to be in an equal amount of a pH of 7. I'm neutral. I'm going to have both. So the question is, well, how do I increase acidity? How do I decrease acidity? And it all has to do with how many hydroxides, OHs, and hydrogen ions, H pluses, do I have. My scale is from 0 to 14. If I'm between 0 and 6, I'm considered an acid. It means I have more hydrogen ions, H pluses, than I do OH minuses, hydroxides. If I'm more basic, which is between an 8 and a 14, that means I have less hydrogen ions, H pluses, and I have more hydroxides, OHs. And we do that by the power of 10. So the pH minus log of 10 is I will increase by 10 as I go up. I will increase or decrease by 10 as I go down. Hydroxides, and it'd be an inverse relationship. pH 7 is the only one where they're balanced. After that, it's an inverse relationship. And that means one goes up, one goes down. So pH of 7. So how does that make water neutral? So here I have my hydroxides, my 1 liter of water. These are how many hydrogen ions are going to naturally ionize. So I'm going to have hydrogen ions, but I'm going to have the exact same amount of hydroxides. Hydrogen ions, hydroxides, I'm going to have the same amount for a pH of 7. So my pH of 7 is going to be in equal amounts of hydrogen ions and hydroxides. They're an even amount, and that's going to give me a pH of 7. If I increase my pH, which means I go up, I become more basic. And my log of 10 is going to increase or decrease by 10. So if I go to a pH 8, that means that my hydroxides are going to increase by a power of 10. My hydrogen ions are going to decrease by a power of 10. I'm going to become more basic than a 7 by 10. I look at a pH of 9. This is going to be 10 times more basic than an 8. So I'm going to have 10 times more hydroxides than I did at 8. I'm going to have 10 times less hydrogen ions than I did at 8. But if I jump from a 7 to a 9, this is 100 times, because 10 times 10 is 100. So a pH of 9 is 100 times more basic than a 7. And if I go down, I get more acidic, I go to a pH of 6. A pH of 6 is going to be 10 times more acidic because I have more hydrogen protons, more hydrogen ions than I do hydroxides. So the power of 10 is what goes up and down. I increase by that much. And it has to do with the inverse relationship of how many OH minuses, hydroxides, and H plus hydrogen ions I have. All right, that is just a real quick overview of pH for AP Bio. Just keep in mind protons in my solution. The more proton ions I have, the more acidic it's going to be. I hope that was helpful. If so, I wish you guys would like and subscribe. We'll talk to you guys later. Bye.